A very good morning to all. My name is AVIK Kundu. I am from Kolkata. I am currently studying in Kalinga Institute of Technology, Bhubaneswar. I am in my third years of Bachelor's of Technology and my specialization is Computer Science and System Engineering. For the TCS Inframinds Round 2, I have chosen the topic as Autonomous IT. So I want to show you the procedure and the life cycle I followed to complete this project. In this project, we have followed the classical waterfall model for the software development lifecycle. According to this model, there are five different phases: requirements analysis, design, implementation, verification, and maintenance. Moving on to the requirements analysis phase. Upon consulting various business lines and also reading the problem statement, I've understood that the business objective is developing highly scalable and secure WordPress infrastructure on cloud services. Upon consulting the various clients who have their WordPress sites set up on various cloud servers since decades, I've come across the software requirements they are looking for in their future investments. First of all, the infrastructure build should be automated. Secondly, systems must be regularly patched with latest updates. Third, infrastructure must have self-healing or auto-scaling properties. And the fourth, the WordPress site should guarantee zero downtime deployment. Moving on to our phase 2, that's the system design. For this project, we have chosen Microsoft Azure Cloud as our cloud vendor. This is because of the following reasons. First of all, Azure has currently three availability zones in India present in Central, South, and West India, thus ensuring a good amount of bandwidth for the Indian people. Secondly, the Azure is 4 to 12% cheaper than AWS, as well as it provides stronger and faster PaaS capabilities. That means it is a very good platform as a service management tools. Third and the fourth is that it gives enterprise agreement. That means most of the enterprise have typical connections or requests from Microsoft about other devices and other products. When they try to use Azure, they get significant incentives. And the fifth and the most important is that 95% of the Fortune 500 companies use Azure. So this thing I have to just. The second reason is that Azure is 4 to 12% cheaper than AWS. The third, Azure gives stronger and faster PaaS or platform as a service capabilities, which nowadays is most important in part of cloud infrastructure. With the enterprise agreement, enterprises can typically obtain significant incentives for using Azure. And the fifth is that more than 95% of the Fortune 500 companies use Azure. Moving on to HashiCorp Terraform. So basically, since we have understood a software requirement for creating a infrastructure which would be highly automated, we can understand that the infrastructure should be written as a code to satisfy the purpose of highly automations. So for that, HashiCorp Terraform is a best tool to create infrastructure as code. It provides a unified workflow using infrastructure as code to iterate over infrastructure safely that is capable of provisioning anything anywhere. Moving on to Ansible. Ansible actually is a configuration management tool. Basically, it's an open source tool similar to Chef and Puppet and Salt. But the difference is that it does not have to install any software to the target nodes, and it uses SSH connection to connect the servers with the target nodes. And the most important thing is that through this Ansible, we can actually patch the systems regularly for vulnerabilities without even personally visiting the systems. Next, we move on to the WordPress architecture. Here we see that the WordPress architecture consists of Apache Web Server and the WordPress, which consists of the app server, PHP, and the database server, MySQL. That means WordPress needs both PHP and MySQL to run. So in this project, we are going to place the PHP and the MySQL servers in different instances connected to a same virtual network to ensure high scalability. Moving on to the final system design which we have generated after the entire system design phase. So this is the actual infrastructure we are going to build on Azure. So first of all, we can see that we will be creating a virtual VNet. After creating a VNet, we are then going to basically create two subnets. One subnet will be a backend subnet, private subnet, and one will be a public subnet. Basically, this private subnet will not have an access to outgoing internet, while this public subnet will have an access to outgoing internet. This is because we don't want MySQL server to communicate with the outside world, since it should be placed in a very secure manner, protected from the hackers. And in the public subnet, we have to make sure internet is accessible, since users are going to enter to this WordPress server to generate and write blogs. So apart from this, we have also used a load balancer on behind which we have made a virtual machine scale set. So this ensures that we are maintaining the auto scaling features. That means whenever the website load increases, automatically new servers will be built, and the load balancer will actually determine the which server will the user's route be routed on the basis of the CPU per utilization of each of the newly created servers. So thus, by setting up the MySQL server and the WordPress server as well as a load balancer on our auto scaling feature infrastructure, we can ensure the highly scalable and secure WordPress infrastructure on Azure. To start with our implementation, we need to first create our infrastructure on Azure. For that, in this project, we are going to use Terraform, which is actually an infrastructure as a code tool. The reason of using Terraform are as follows. Documentation. All our resources required to set up the infrastructure can be serially written down so that it can serve as a documentation in the future years. Maintenance. Since the infrastructure get documented, maintenance works gets easier and resources can easily be upgraded through code, and we can stop or start infrastructures with a single line of code. The language we use in Terraform is HCL, which stands for HashiCorp language. It's more like JSON and YML, that is, they have a declarative way of writing syntax. We need to create a main.tf file to write all our codes. We just have to execute this file to set up the infrastructure on cloud. In the first line of our main.tf file, we can see that we have used a Azure RM provider. Actually, we are needing this provider because when we are installing Terraform in our computer, we are just installing the Terraform core unit. So, to inform Terraform that we want to connect it to Azure, we need to download their provider, which Terraform has built officially to connect it with the Azure APIs. So, for that, we are using this Azure RM provider. So after connecting it with our Azure RM service, we just have to run one command, that is terraform init. Terraform init command will actually initialize our computer to interact with the Azure RM for this project. Moving on, After we have successfully connected our Terraform unit to the Azure RM, we need to first of all create a resource group. This is a very important and a very good tool provided by Azure. Basically, all the resources we are going to create in our infrastructure will be listed down in a single folder like structure that is known as a resource group. The advantage of creating resource group is that we can manage all other resources together at a single place, and also we can just delete all the resources together with a single click of a button. Moving on, first of all, we have to create a virtual network in our infrastructure. This is a very important stage because the virtual network will be connected to each and every resources we are setting up in this infrastructure. So let's move on for creating our first virtual network. From the figure here, we can see that the topmost resource which we will be creating is our virtual network. To create our virtual network, we have to use this syntax. Basically, here I am stating that my name of the virtual network will be Tata VNet, and I will be giving an address space and a location, and I'm also going to attach it with the resource group I have created earlier. So by executing this code, the virtual network will get set up. So after setting up the virtual network, now we have to actually set up two different sub networks inside that virtual network. The need of creating two different sub networks is very simple. This is because we want to create a scalable and a secure application. So first of all, let's look how to create a secure application. For an application to be secure, we have to protect it from the different attacks that can happen it when we are connecting a service server to a internet. So in our infrastructure, the most important or the most crucial server will be the server where my database will be installed. So by hook or crook, we have to protect our database server. So for that, we need to actually set up our subnetwork in such a way that the database server does not have any access to the internet. This is because a database does not need to access the internet at any time, because a database will be only be connected with my WordPress server, and the WordPress will be communicating with my database to the internal private network which we have already been created through the virtual network on the top. So we don't need our database server to be connected to the outside world. So for that, we will be adding this resource or the database server to a private subnetwork or a private subnet. While on the other hand, our WordPress server will be deployed in a public subnet where it can access the internet from the outside world, so that people from the outside world can directly connect with the WordPress server through the IP addresses. So from here we can see that this is our code for creating a public subnet, and this is our code for creating a private subnet. You can notice here that I have given the subnet as 192.6.168.1.0 for the public subnet and 192.168.2.0 for my private subnet. Now comes the most interesting part. Creating subnets does not ensure that we will be protecting it from the outside world. We now have to create the firewall, or to be precise, we will be now creating the rules which will act upon this subnet and protect it from the internet outside. So for that, we have to set up network security group for each of the subnets we have developed. So for that, we need to first of all set the network security group for the front end subnet. From the code, you can see that we are trying to create a NSG front end or the network security group front end first. We are also connecting it to the same location and the same resource group name. Here we are telling that my front end subnet can connect with the outside world through HTTP protocol, as well as through the HTTPS protocol, and as well as SSH protocol for now. After that, we will be creating our backend network security group for our private subnet. For the backend energy or the backend network security group, we will be setting up the network security group in such a way that only MySQL connection is available. So for that, in our security rule, we are mentioning it to be a MySQL access only, and we are opening only 3306 port number. Apart from that, we are temporarily allowing SSH protocol so that we can get inside the VM and set up our MySQL. But after setting it up, we will be removing this SSH protocol because it will be not required after that. And after that, the most important thing is stopping the internet access. That means for this VM, we will be stopping all access, outgoing internet access on this VM. That's why you can see that we will be mentioning the access as deny and TCP and all types of ports and destination ports. Okay, so after setting up our virtual network, the private and the public subnets, as well as the network security groups, now is the time that we must now deploy our virtual machines in each of these subnets. So for that, we are setting up the server VM on the front end subnet so that we will be installing our WordPress and Apache web server in this VM. So for that, we are also mentioning a username password, as well as we are mentioning to the VM to use the Ubuntu server 18.0 for LTS for the reference security image. So we are telling the VM that we need to set up an username password as such, as well as we are also telling it that to install Ubuntu server as the base OS on this VM. So after setting up our virtual machine for the front-end WordPress system, in the similar manner, we are also setting up our backend VM or the backend virtual machine in the private subnet where we'll be installing our MySQL database. So we have successfully set up our virtual machines as well as our virtual subnets as well as our network security groups. Now is the time to deploy our last and the final resource, that's the most important one, that is the load balancers. Azure provides two types of load balancers. One is a basic one and one is a standard one. We are going to use the basic one for first creating our load balancers. In this piece of code, we can see that I'm declaring a load balancer data LB and I'm attaching it to a front-end public IP configuration. So basically, I am connecting this load balancer with a static IP address which I have just declared here. After this, our load balancer will be created. For understanding what is load balancer, we can refer to this picture here. We can see from here that whenever a client contacts the load balancer through the public IP, the load balancer decides which server will the client be going to get the response on the basis of the server loads at the present time. For example, suppose when the client wants to get some information from server 1, the load balancer sees that a server 1 is already being overloaded, it will send the request to server 2. So by this, the client will receive the response from the servers without any delay. So that's the benefit of using load balancers. We are going to set up load balancers behind the virtual machine scale sets, which we will be generating a little bit later. Thus, this will be allowing us to ensure the feature of auto scaling. This will be basically helpful for creating a highly scalable WordPress development infrastructure. Apart from just adjusting the load balancers, we also have to set up the backend address pool or the place from where the load balancer will understand the virtual machines to be sending the requests to. So for that, we are setting up a backend address pool, and we will be connecting our virtual machine to this backend address pool so that the load balancer can traffic the routes in this virtual machine. After that, for the load balancer to work properly, we also need a health probe. So this will be like a watchtower. It will keep track of which server is getting overloaded, and it will confirm the load balancer, which in turn will divert the load to the other server. Moving on, we also need a load balancer rule. So this rule basically will check that the load balancers is properly functioning and is properly routing the port numbers to the exact server that has been deployed in the backend pool. Apart from that, we are also will be needing some network cards for connecting our virtual VMs with our subnets. So for that, we have configured some network interface cards or NICs. We can see that we have given a dynamic IP address to this network interface cards just so that we can connect to these VMs for the initial setup of the WordPress. But after we complete our setup, we will be removing all these backend dynamic IP addresses, thus making our site more secure. So apart from this, we have also used a lot number of intermediate connections that are mostly used to connect from one's in resource to other. For example, this connection network interface backend address pool association. So this connection basically integrates our network interface card with the backend address pool. Like this, we are having numerous associations in this code which will be helping us to associate a particular resource with the other. So this completes our whole Terraform setup. So after setting up our Terraform, we just have to first run the command Terraform Plan. This command will actually visit the previous state which has been already been stored in the Terraform directory. It will compare the current codes with the previous state and find out which are the changes it requires to change in the Azure portal. And after noting all the different changes and updates, it will list down everything in the console. We can study and understand the different changes that will be brought down if we execute this code instantly. So when we are satisfied that the changes are positive, then we can directly execute the command Terraform Deploy. So this command will actually deploy all the different changes to the Azure portal, and thus our infrastructure will be totally being updated. Thus, finally, we have successfully finished setting up our cloud infrastructure on Azure portal by using an infrastructure as a code tool with Terraform. Now, let's move on to using Ansible. That is basically a configuration management tool. It will help us to connect with the virtual VMs we have just deployed, and will help us to basically update and patch those VMs without directly entering those VMs from the console. So now let's go and see that code. For setting up Ansible, we first have to make a hosts file and mention the private IP addresses of the virtual machines on which we are trying to patch the systems. So first of all, I'm writing the private IP addresses of my database server as well as my WordPress server. Apart from that, I am setting the Ansible username as Azure user, since this is my username for all both of these servers. After creating this host file, then we can move on to the main.yml file that actually contains the code for the Ansible to work. So basically in this code, we are trying to tell Ansible that to connect with these virtual machines and update the packages list as well as upgrade all the installed packages. So this is the most important code part. Basically, it informs Ansible that Ansible should go to each and every virtual machines listed in the host file, and it will connect to the host file through SSH. After connecting it with SSH, Ansible will run the command apt-get install in both of these virtual machines and then run apt-get upgrade in all the virtual machines. Thus, all the virtual machines will be upgraded and patched with the latest versions of the softwares within a single click of a button. So that's the benefit of using Ansible. It helps us to connect with multiple virtual machines within a single click of command. So moving on to the practical application, from here we can see that when I run this command, Ansible playbook asks pass I host y main.yml.check, and after that it asks for a password. After I give out the password, basically it starts first by gathering the facts. After gathering the facts, that means it first starts by going to the server and understanding whether it can be accessed or not. So here we can see that it gives an OK signal for both of these servers. That means Ansible could be able to access these servers through SSH. After that, it runs the first task, that was the update packages list. So basically, after that, it sends a OK message. After that, it executes the second task, which was upgrading all the installed packages. Also, it becomes successful and returns with OK. So after completing everything, it gives us a recap that in both of these virtual machines, all the tasks was completed and none of the tasks failed. So that was the short introduction of Ansible and how I set up Ansible to automatically patch the systems using single update patches within the Ansible playbook directory. So now let's go to the Azure portal on the web and check whether all the resources have been created or not. When we visit our resource groups, here we can see that our resource group has been created. And then from here, all the resources that has been launched are all listed here. From here, we can just go to the server VM which we had created. We can easily copy the SSH IP address from here and then use in our terminal to open that VM in our command prompt. After that, we do the same thing with the database server, which we have also set up in through the Terraform. So that is actually listed here. So DVVM, the same thing, we can copy the IP address and then open it in the command prompt. So I have done it before and I have kept it online. So after we set up the virtual machines in our command prompt, then we can easily install WordPress in it through different commands. Suppose if you want to install Apache, we can easily type here apt get install httpd. So basically you have to add a sudo before, since I'm not a root user right now. And after that, when we press enter, it asks that it has already been installed before, so I don't want to install this again. So basically in the same way, I have also installed MySQL before in this server. So after setting these servers, then our next job is to actually ping those servers and see whether the Apache web server is running or not. For that, we can just copy the server IP address from here and then open the browser and just go to this IP address. From here we see that we can actually access the Apache default page, and then if we just make a route to WordPress, we can see that the WordPress setup has been configured. So right now we can easily set up the WordPress from here. So thus we have successfully set up WordPress on our cloud infrastructure. Now our next job is to create an auto balancing system so that we can assure the self-healing nature of our infrastructure. So for that, we will be using the Azure resource known as virtual machine scale sets. Basically, this allows us to create a auto balancing group so that we can easily use different we can use a load balancer to connect to different virtual machines connected to the load balancer backend pool. And the benefit of using virtual machine skill sets is that it can automatically launch a different instance when my load on the website will increase, as well as it will decrease the number of instances when my load to the website decreases. So basically, it can scale in and scale out our infrastructure. So to set up this first, we have to actually make a custom image of the WordPress we have already installed in our VM. So we can head over to the VM on which we have just set up WordPress, and then we can capture this entire VM together so that we can create a custom image of this VM. So since I have already created, I will be not creating once more. So after creating a virtual machine AMI, then we can actually create the virtual machine skill sets. From here, we can easily select the option of creating a virtual machine skill set, and then after filling up this form, we must have to ensure that in the image section we select the WordPress image we just have created before it. So after we select this WordPress image and then create the resource, we will be totally go with the creation of our first virtual machine skill set. As you can see, I've already created one before, and when I click on it, you can see that we have already one instance running right now. And if we go to scaling properties, we can see that we have set the scaling properties as such that whenever the scale or whenever basically the load of the system increases more than 70%, that means the percentage of CPU increases more than 70%, my count, the number of servers will increase by 1, and whenever the percentage decreases less than 69%, the count will be decreased by 1. So all these features were able to be done possible with the help of the virtual machine scale sets available in the Azure portal. So thus we have successfully able to create a secure as well as a highly scalable WordPress site on Microsoft Azure portal. Now let's move on to the testing part of our SDLC lifecycle. For this, we are going to use the Azure DevOps portal. In this portal, under test plans, we have an option of load test. So load test is a kind of test which will actually test whether our virtual machine skill set is able to functional or not. That means whenever the load of the system will increase, is the virtual machine skill set is able to create a virtual machine or not. So for this, Azure DevOps has a good tool from which we can use a URL based test, and on select placing our URL of our IP address of the virtual machine skill set basically here, we can actually undergo do a load test on this machine and check whether this machine is working perfectly or not. So for that, we just have to copy the virtual IP public IP addresses of the virtual machine scale set present here, and then we after placing it here, and then when we run the test, we can easily see that the number of instances here will increase, and once the load test completes, the number of instances here will decrease. I'm not able to run this right now because I've exhausted the plan, but the works will be similar like this. So that concludes my prototype explanation. So the final deliverable after this project was a highly scalable and secure WordPress architecture set up on Azure Cloud Platform. This statement is exactly matches with the business objective we had stated in the systems requirements phase. So thus we can now tell that the project has been successfully completed. I hope you liked my video. Thank you and have a nice day.